Okay, welcome back from lunch. Alex Jacocks is going to talk about 3D printing for fun and profit. Okay, just for fun.
So as Martin just said, I'm here to talk about 3D printing, and particularly I'm going to talk about 3D printing as it applies to vintage computers. Really doesn't matter. It's pretty much the same everywhere, but some techniques are more or less applicable. The thing I'm hoping that you all will get out of this is the fact that it's really not very hard to get started doing this. You all have all the specialized knowledge necessary, which is knowledge of the system or knowledge of whatever it is you're trying to build, and that's really the most important thing. So, brief history of 3D printing. It may be older than you think it is. I did not realize that 3D printing really got started in 1981. We have Hideo Kodama. He basically invented the idea, or his institute. It's not really clear how much is him specifically, but his name is on the original paper, describing a rapid prototyping system that uses photopolymer. That's what will eventually become SLA. There's not clear whether he actually built it or not, but he described it in detail. 3D Systems founder Charles Hall invented stereolithography, and then created the STL file format, which is the standard file format that most 3D printing is done with. It describes 3D objects using triangles. The founder of Stratasys, I don't know, has anyone heard of Stratasys or 3D Systems? Okay, at least somebody. So Stratasys and 3D Systems are leading professional 3D printing manufacturers. Stratasys, as far as I know, is the largest in the world. Anyway, Scott Crump invented FDM 3D printing, or fused deposition modeling, which basically is like extruding plastic. So, if you think about squeezing a tube of toothpaste, that's FDM. And then in 1992, 3D Systems created the first useful stereolithography machine. So it took between 81 and 92 for the idea to become practical. And stereolithography works in that you have a photopolymer, which is a liquid resin, and then you have either a laser or a DLP, and it basically heats that resin to solidify it. And it does that layer by layer. So slice and build up. So as I mentioned for stereolithography, it's only recently become practical for home use. The stereolithography has traditionally been very, very accurate and very high detail, but it has been very expensive. The printers themselves have come down in price. There are several that are available for less than $1,000 now for home use. However, the resin still is kind of pricey, and it's very manufacturer proprietary. So you need to use generally the manufacturer's resin unless you want to get into the realm of experimentation. Also, you tend to throw away a lot of resin every time you make a print. But the trade-off is the fact that if you're doing very detailed models like action figures, or like even something like a tiny gear out of a 3.5-inch floppy drive, we may all be familiar with those failures. SLA is the best way to do that. It produces the highest detail of reasonable home technologies. So SLS, this is still pretty much a professional technology, but it's been around for quite a while as well. SLS is basically laser 3D printing. A laser melts some kind of a dust or particle-based material to produce an object. You start with a vat filled with dust, and you focus the laser, and it moves around, and the object slowly appears. Is basically the way it works. And it tends to waste a lot of material as well, but it gives you the greatest ability and flexibility with materials. You can use SLS and produce objects in gold and iron and anything you want, anything a laser can fuse. And these are very high power lasers. We're just starting to see SLS become practical for home use. I was at the East Coast RepRap Festival a couple weeks ago, and there was a guy doing a demonstration of a former commercial SLS machine that he'd gotten at an auction for very inexpensive, and he brought it home, and he's been working with it, and he's had some success. But still an emerging technology. FDM is what I'm mostly going to talk about here, and that's what most people think of when they think of 3D printing. FDM works with solid plastics in the form of a filament, usually comes on a roll, and it takes that filament, it heats it up in a heat chamber within a hot end, and then it extrudes out the tip. And the tip is a narrow diameter. Can be as small as 0.1 micron in common use, or even smaller in specialized devices. And it basically extrudes it again like a tube of toothpaste onto your bed to form an object. It builds up layer by layer. The plastics you can use with FDM are really varied. There's amazing variety. I mentioned here PLA, PET, and ABS. Has anyone heard of PLA or PET? Okay, for those who have not, PLA is a plant-based plastic. It's one of the great advantages of it is it's fairly non-toxic, although we're not talking about any FDA, food safe or anything like that, no matter what you may read. Nothing is ever food safe unless the whole machine that produces it is food safe, and whoever wound the filament produced it in a food safe environment. But generally, I feel safe enough making tools for kitchen use out of PLA. However, the problem with PLA is two things. One, you can't put it in the dishwasher if you make kitchen tools with it, it will melt. Two, like all 3D printing technologies, there are voids in them. So you have to be careful when you wash things. So it's great if you want to make measuring devices for water or things like that, or for dry powder, it's not such a big deal. But, for other uses, it's questionable. It is a very flexible plastic for most purposes. It's actually very much stronger than some of the plastics that people think of as being very strong, like ABS. That's ABS, the Apple IIc. That case is ABS. ABS is very commonly used in injection molding, and it certainly is very usable on home printers. However, caveats. One, printing with ABS produces fumes that are definitely hazardous. You have to vent them. You do not want to print ABS in closed space. It's quite bad for you. Two, ABS is extremely sensitive to temperature change. So when you print it, you have to enclose your printer for the most part, or you've got to heat up your room. Because if you get a breeze while you're printing, your item is going to warp. You're going to end up with something that's not stuck to the bed, and your flat base for your case is going to look like a banana. PET is the other type of plastic that I use often. It is a sort of a halfway in between. It is not quite as strong as PET, but it's as PLA, but it's stronger than ABS. And it's also, it's better as far as temperature resistance in the final product than PLA is, but not quite as good as ABS. So it's also fairly easy to print. It's also, all these three plastics are fairly inexpensive. There are other alternatives like nylon, like carbon fiber infused, there's wood fill infused filament. A lot of those infusions are actually PLA with some kind of a material added to them, wood particles or even gold particles or silver particles. I think that's it here. Hardware. These are things you need that are not printers. Number one thing you need, of course, is patience. I put that all the way down the bottom, but that's the number one thing.
Okay.
Especially when you get started 3D printing, you're going to create a lot of unusual objects. They're not going to work the way you want them. Your printer's not going to work the way you want it to. You're going to get frustrated and you're going to want to give up. Just keep going through that. I went through that. I think everyone went through that when they started printing. It just takes time to learn the tools and learn what they can do. It is a lot easier than it was, say, 5 or 7 years ago. There's a big difference. Modern printers do things like auto bed leveling, which is a really amazing advance. You wouldn't think it would make a real big difference if your print surface is absolutely flat, but it does. If your print surface is not actually absolutely flat, things will fall off of it, and you can create horrible, horrible messes when things come loose. So, things you need. Calipers. I would suggest digital calipers. I have a link here in the presentation. I'm going to share that. I suggest calipers that are absolute origin, meaning you don't have to reset them, because otherwise you're going to forget to reset them. And digital calipers, I think, are easier to use than vernier calipers, but your opinion. You can do whatever you want. A ruler. Just get a really good ruler. I like metal rulers because you can't beat them up easily. Blue painter's tape is always handy. If you have trouble getting things to stick to your printing bed, you can put blue painter's tape on it, and a lot of things will stick to painter's tape. A lot of folks who've been doing 3D printing for a long time will suggest Kapton tape. I don't know is anyone here familiar with Kapton tape? Okay. It's orange stuff, orange transparent tape. It's heat resistant. It's quite often used in electronics. If you open up a laptop and you see tape around a heat sink, around a processor, that's Kapton. So it's readily available, and it's another tape that your 3D prints will stick to very easily, but it doesn't produce the best finished objects. I'll pass this around. This was printed on Kapton tape by the facility. And by the way, the model I'm passing around is it's a case for Nishida Radio's 2C VGA adapter, which I absolutely adore. PVA glue stick. That's just regular Elmer's glue stick that you probably used when you were in kindergarten. It actually will make both prints both stick better and stick worse. Sometimes sticking worse is a good thing. For example, depending on what is on your printer's bed. It may be something like, a piece of aluminum, it may be a sheet of glass. Those need help in sticking. However, when you get some of the plastic bed materials, things like PEI, which is what I use, it's basically a plastic sheet with some texture on it. Things like PET, plastics like that, stick entirely too well to PEI and will become permanently attached. So if you put down some glue stick, you just rub it on, make a horrible mess, before you start printing, your object will come off. So it can be very helpful. Tweezers. All FDM printers drool. It's actually kind of funny. When you see the printer heating up, you get this little tail of plastic that's going to trail on. It will absolutely fill the bottom of your printer or the room that it's in or anything with tiny little plastic bits. They're everywhere in my house. It's one of the reasons I particularly like PLA, because I don't have to worry about my cat or my daughter eating them and being hurt by it. Putty knife. Putty knives are really good for removing things from printed beds. And again, I already mentioned patience. Printer suggestions. This varies really widely. These are just valid at this point, as of 2018, but I will suggest a technology. When you start printing, go with a Cartesian 3D printer, as in one where the head moves left and right, forward and backwards, up and down, or the build plate does the same. There are a lot of other types of 3D printers. There are Delta printers you may see. They look like the tripod over there, and they have basically in the tripod upside down, and then the hot end hangs from the top of the printer. They can move really fast. They have some great advantages for printing. They're much more complicated to calibrate. So leave that for your second or third printer. There are also what are called Core XY printers, which are cube, which have really amazing belt routing where the belts run all over the place and double back on themselves. They're neat. They can be high speed, but standard Cartesian printer is a lot easier. So I will recommend, first of all, the printer I have, the Prusa i3 Mark II, Mark IIs, Mark III. It's a really, really, really good, reliable printer with a heck of a lot of automations. You don't have to learn. However, it's not cheap. It starts at about $600 and goes up from there to about $1,200. Second one, there's a Chinese printer. I know this might be controversial to anyone else who does 3D printing, but I actually do like this printer. I don't have one personally, but I have a lot of friends who do. It's called a Creality CR10. You can buy them on Amazon. They will be shipped from China, so you will have to deal with a Chinese manufacturer. But Creality has actually been a fairly good citizen as of late in the 3D printing community. There's a big problem with a lot of Chinese 3D printer manufacturers just ripping off other people's creations. Creality has been much better about this than the others. However, your mileage will vary. It's a foreign company. You don't have any direct access to them. There's a new company called Cetus. It's another Chinese company, but they're more legitimate. They're like fairly mid-sized Chinese company. They deal regularly in the U.S., so you can get service. They have a neat linear rail-based 3D printer, so it produces really thin, really fine, smooth finished objects. It's called a Cetus Mark III. It's about $360. And then Monoprice. I bet a lot of people have ordered from Monoprice. So they have a small printer called the MP Select Mini V2. It's about $200. It's also linear rail-based. It's not quite as high quality of an object as the Cetus, but it's $200. It's a great way to get started. Micro Center actually has several very usable printers. They're all generally from a Chinese manufacturer called Wanhao, but they're supported by Micro Center, so you don't have to worry about them, and they start as low as $150, and they all work fine. This will definitely change over time, but this gives you an idea of where to start looking. The best way to find out what the best printers to use is to find out what other people are using and having success with. If you have a makerspace near you, go see them, go see what printers they have, go talk to the people in the makerspace and see what they like and what they've had issues with, or you might have a local printer manufacturer based on the makerspace. In Hammerspace, in Kansas City, is based a 3D printer company called Oni. So, would be probably a decent printer to have if you live around here. CAD. So you have to draw your objects. Does anyone here have experience with CAD, 3D CAD in particular? Okay. Well, if you don't, it is a bit of a thing to learn, as you probably know. Depending on how you feel about doing your CAD work, whether you want to draw it, like a traditional vector drawing program, like MacDraw or something like that, or if you want to input coordinates, or if you want to write programs, you pick different programs. The first one I'm going to mention is called OpenSCAD. It's referred to quite often as a programmer's CAD package. You can literally create loops and functions to create objects. It's kind of a neat thing. This is OpenSCAD. It's one of the objects that I've made. It's a badge case for a VCF Midwest badge this year. But as you can see, I don't know how well the folks in the back can read, but you see I've got functions here. It's actually a module, so it doesn't take any parameters. And you can see I call functions, and when I create an object right here, that's a cylinder. That's how you start. I have to give parameters. You see all those variables and all that math. If you think like that, and I do, this is really good. However, OpenSCAD is terrible for creating art. Really not functional in that way. But if you want to create screws or anything mathematical, OpenSCAD is wonderful. Next one, Fusion 360. A lot of folks may have heard of it. It's an Autodesk product. It is free, as in free to use, unless you make over, I think, what, $100,000? Is that right, Charles? Something like that.
I'm way under their limit myself.
Well, if you do what I do and make zero, then it's no problem. But it is a very powerful CAD program. It's fairly easy to get started on, and it has the advantage of the fact that there are a ton of tutorials out there on the web. There's YouTube videos, there's books, there's everything to get you started. This is Fusion 360. Let's see. So normally the way it works in Fusion 360 is you start, I don't know if you can see down here, I have a sketch down in the bottom of the base of this model. And this is the model that I passed around. So what you do is you figure out where all the openings and all the transitions and all the angles are, and you draw them in 2D first. And then what you do is from that, you extrude upwards. As you go up, you can create new planes anywhere you want and create a new sketch on top of that plane and extrude from there. So you can create some really amazing objects. And for the kind of simple stuff that most of you want to do for vintage computer enhancement, it works really easy. As I said, you know, there is a bit of a learning curve. It's more to get started than some of the others, but it's really, really, really powerful. You will have to deal with some bugs, though. I have Fusion 360 crash on me pretty darn often. Others, Sketchup is surprisingly popular. I don't know if anyone has used it. It used to be owned by Google. What do you particularly like about Sketchup?
I like that it seemed to be really popular, so that's one of the options I was brought up when I was asking around. But I still have an old copy of SolidWorks.
Yeah,
I usually
yeah.
make all of my stuff with SolidWorks.
If you have SolidWorks, that's fantastic. If you have any pro-level CAD or engineering tool, you can even make objects in Blender. I don't know if anyone here is a 3D artist. Blender is fully capable of making printable objects, no problems. Tinkercad's another AutoCAD made product, and it's entirely web-based, which is kind of nice. It also has the advantage of the fact that you create objects by dragging 3D objects onto your into your virtual build area and combining them or slicing them or multiplying them, whatever you want. So it's fairly easy to get started. The main limitation is that you can only create 200 millimeter cubic objects. Slicers. So this is something that is specific to 3D printing. You have to slice an object. As I mentioned as you go along, all the technologies we're talking about here, be it SLS, SLA, or FDM, they work by slicing an object into effectively infinitely thin slices. And then you build up that object, slice by slice by slice as you go. So when you have an object and you create it in a CAD program, you output it as an STL. As I mentioned, that's a standard file format. And then you have to take those STLs, which consist of triangles, and turn them into flat slices. That's what these programs do. These are the most popular ones that I'm aware of, and I've used all of these at least once. So the first one is Slicer. Second one is Cura. We have Simplify 3D, which is commercial paid for. Slicer, Cura, and Repetier are all open source, and I recommend them highly for that reason to start with. And then we have Octoprint. Octoprint is a little bit of a special case. It is a slicer, but it is also a program that you can put on a Raspberry Pi and make your 3D printer wireless if it doesn't have that functionality built in. So you'll probably encounter it no matter what at some point. It's a really neat piece of software. This is Slicer. This is what I use most often. You can see the back plate. This is from the 386 case that I built. You can see the ISO slots there. You can see one of the important things when creating objects and laying them out for printing is to put them properly on the build surface. I'll talk about that later in my tips section. But you can see the back plate is laid flat on the surface. What you're seeing here is, this is a preview, so it's showing these yellow are standard printing, standard layer printing. The red is a top surface. Something you don't see here, but I can't really see it in here, are supports. Supports are really important. Everything has to touch your printed surface. I'll get into more on that later. If it doesn't, you've got to put plastic underneath of it. You can't leave plastic hanging in the air, especially because it's hot. I'm sure you can guess it'll sag. So that's what supports are for. This is Cura. Cura is made by Ultimaker. They make some, I would say, prosumer 3D printers. Very well made machines, but they're very expensive. But the piece of software they make, Cura, is open source, and it's really nice. Its advantage is it does supports better than most open source packages. This is Simplified 3D. It is like a semi-professional slicer. It's about, I think, about $250. It seems fairly popular. I've not used it much. I've not seen a need. And I'm a really strong open source believer. So, design. So if you think about it, if you've ever done woodworking or metalworking before, you already have the principles of making objects. Things that are specific to 3D printing you have to think about. Number one, I mentioned warping. So warping is caused by an object losing contact with the build plate. So whenever you create an object, as you saw in my previous example right here, you got to lay the object, the biggest flat surface you have, lay it flat on the build plate. That is the most important thing. So when you get an object from someone else that may or may not be in the right orientation, flip it around until it sits properly on the plate. If you don't have a flat surface, say you wanted to print, say a key from a keyboard, that's a very common use case. I have made a number of keys for replacement. I have a ZX Spectrum 128 that has some missing keys, and I printed keys for it. Also the power switch on one of my IBM PS2s. They really don't have any large flat surfaces. They're hollow objects. So what you do is you create a raft. Basically what a raft is the printer lays down a bunch of layers of flat plastic on the build plate that are throwaway, and then it puts the object on top of the raft, and that way the objects stick. Let's see, actually. Make sure if you have a heated bed, heat it up properly to the right temperature. When you get filament of any type, there's going to be a sticker on it. It's going to tell you, make the hot end this temperature, make the heated bed this temperature. If you don't have one, you can print PLA just fine without a heated bed. A lot of the lower end printers, including a couple of the Micro Center ones, do not come with a heated bed. So you can print PLA just fine without it. You just have to be a little bit more careful about prepping your bed. You have to make sure it's clean and then maybe apply PVA or apply some painter's tape or some Kapton tape. Warping is especially a problem with ABS. So again, as I mentioned this before, I'll mention it again. If you're doing ABS, you got to get the environment hot. Most ABS is done with printers that are enclosed rather than open frame printers. Or alternatively, if you have a room in your house you're willing to make 85 degrees, do it. You'll get much better prints. Or you can put your printer in a bag, but it's really, really, really unsafe. If you think about it, there's a heating element in that printer. Who knows what could happen? Who knows when that bag goes? And that is something I should actually bring up before all this stuff. Safety with 3D printers is really important. If anyone's been following the industry, there's a Chinese printer recently that's been a little bit famous for burning people's houses down. It's called an ANET A8. Basically what the problem is that when you have a hot end, and this is the case actually with heaters in your house, heaters in your car, normally there's a fail-safe on all those heaters where if the device can't see how hot the heater is, or it's not gotten any return from the heater, or it's drawing way too many amps, it will shut that heater down. A lot of the cheap Chinese printers do not have that. It's a silly thing. They're using open source firmware that makes it available, a firmware called Marlin in the most case, but they turn it off. Who knows why, but be very, very careful with that. If you buy a printer from a reasonable US company, this is probably not something you have to worry about. But what I will suggest, two things. One, keep your fire extinguisher nearby the printer. I've never had to worry about that, but keep one. Make sure there's a working smoke detector nearby. And also, I suggest putting some kind of webcam, like the one we're using for this session. I watch all my prints. If I'm not in the room, I'm watching it on webcam. So all those take care of the problem. You can go, Eric?
Yeah, I've actually seen where someone has a printer where all that stuff was disabled and a MOSFET failed to melt down the hot end.
Yep. And even if nothing really bad happens, that's extremely annoying. You can create this huge mass of plastic that will actually destroy parts of your printer. Because large parts of 3D printers are plastic. And it's a bit of a tangent, but there's a good reason for that. The original creation of all this home 3D printing is via an open source project called the RepRap project. So the original objective was to make printers that, for as much as possible, can replicate themselves, hence RepRap. And so therefore, that's why we make a lot of these components on printers with plastic. It also means that as you get better in 3D printing, you can and probably will upgrade your printer by printing new or redesigned components. It's a lot of fun. You could design your own printer entirely, and it's worth doing. It'll make your printer work a lot better. So again, fire safety, number one thing to worry about 3D printing. Unnecessary overhangs. I mentioned overhangs already before. I don't have anything really here to show with, but if that model I passed around, if you printed it the other way, so the hollow side was down, the entire top surface would basically slip down, slough off, whatever, would hang down when you're printing. Because it's hot plastic, it's gonna run. So make sure you get it flat on the surface. Overhangs are something you're gonna have to deal with. Again, if you look at this Apple IIc, you'll see even if I put the large flat surface on here at the top of this computer on the build plate, it's still got rounded edges. That's okay. It's not a big deal. It's also got this indent where the floppy latch is. That's fine too. Anytime you're going to have that sort of an indent, if you work up to it and you have say a 45 degree or less angle leading up to it, so 45, 60, 75, 90 degree angle, then it's fine. Your printer can handle overhangs. Those will work. But when you have it straight up and down, you try and put a cap on something, it's going to sag. You can turn on supports. As I mentioned previously, and your printer will then put plastic underneath that overhang. However, then you got to remove those supports. It can be a bit of a pain. Rotate your object. I already mentioned that. Just think about this when design. Go ahead.
Does it just automatically decide where the supports should go?
Yeah, absolutely. On most slicers, you hit the button that says supports. It says OK. So all it really does is it slows down when it's putting in supports. And usually supports are like a half layer off everything else, and they're not nearly as dense as your printed model is. So you can usually just break them out. However, when you're making screw holes up into things, which is a very common thing with computer parts, it can be a real pain to clean out supports. So whenever possible, you should avoid them. There's all kinds of neat techniques I could get into to avoid the need for supports altogether. You can do things like, if you have a hanging object, you can put a one-layer support in your model. So if you're making a screw hole again, you can put a one-layer piece of plastic in there and you just drive the first screw right through it. Because one layer is 0.2 millimeters, 0.1 millimeters, something like that. Not strong at all, but it's enough to help your hole hold up. Properly set up your printer. That's a really, really important thing. Most people have problems with printing because their printers are not level. It's the number one problem. So when you get a printer out of a box, when you get it from someone else, when you get it used, the first thing you should do is go through and calibrate the printer. Make sure your build surface is level. Make sure it's going to the temperature you think it is. Make sure it's putting out the amount of plastic you think it is, because it has a stepper motor. Is everyone familiar with what a stepper motor is? Okay, well, for the ones who are not, a stepper motor is just a regular electric motor, except for the fact that it's geared. So if you turn it and you feel it click, 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 hard drives and floppy drives use stepper motors, older ones. And that's what controls the movement. A stepper motor is not the same as a servo, which you may be familiar with. Servos are closed loop in the fact that they always know where they are. Stepper motors don't, but if you send them 10 pulses, they should move ahead 10 steps. So anyway, make sure that when that stepper motor turns and it pushes out plastic, it's pushing out the amount that you think it is. It's really easy to check. You just put a piece of tape on your filament, run the stepper motor 50 steps. You can do the math, determine how much plastic should have come out, make sure that's right. If it's not, change the multiplier. All the printers have a easy way to do this. All the major printers do. When in doubt, print slow. It's sort of counterintuitive. Everyone wants quick returns and objects to be finished quickly, but slower printed objects come out better. Their final is in the final surface finish. Also, they have many less problems. Don't print at the most fine details unless you really need it. It's perfectly fine to print, especially large objects, like, again, computer case, at 0.35 or 0.4 millimeter even layer heights. That's a big, fat layer. You can also use a big, fat extruder head. So I talked about 0.4, 0.2 millimeter diameter extruder head. There are ones all the way as big as 1 millimeter or more. And for a large object, that'll make your object print a lot better and a lot quicker. I said, again, good model design. And then these are BuildTech and PEI. I already mentioned PEI. That's the heated bed surface I use. BuildTech is another one. They're both plastic sheets you can put on your bed to help things stick. Reuse other people's objects. If an object is well rated, and again, I should have linked earlier to Thingiverse. Go look on Thingiverse. If anytime you're thinking about making something, make sure someone else hasn't already done it. If they have, take it and use it. I put all of my stuff on Thingiverse. I know Charles does too. They all have, it lists whatever the license on the object is and how you can reuse it. Most of those are some Creative Commons license, so it's pretty easy to reuse and modify whatever way you want. But you can also, even if you don't like what someone else did, start from what they worked from. There's quite often a lot of comments on the objects you can see where people have said, hey, this doesn't print well, or this object isn't strong enough, or something like that. But you can take their object and modify it. If they give you the CAD file for it, it's really easy to modify. Quite often you'll see Fusion 360 files there, or OpenSCAD files there, very commonly available. If they don't, one of the great uses of one of the CAD programs I mentioned, Tinkercad, you can fairly easily modify STLs, which are not normally something you edit. But Tinkercad can do it. You can add or remove objects and make things work better. Netfabb. Whenever you get an object and you go to printer and all of a sudden your slicer gives you a big exclamation point or marks something bright red, it's probably because there are what are called broken triangles in the object. So that means whatever CAD program generated the object, made the final output, it didn't generate a proper solid object. There are holes in it. So Netfabb can fix that automatically. In most cases, if you take an object that's got holes in it, you load it in Netfabb online, upload it, download the resulting object, it's fixed. It fixes a lot of problems. You do have to look, because sometimes it will do strange things, especially if there are a lot of holes. I've had it rip a model in half. So you do have to look at it, but it's very useful. So here's some example projects. This is the badge. That's the VCF Midwest 6502 badge that I made the case for. I designed it in OpenSCAD. Again, as you can see, it's a circular object, a lot of geometric shapes in it, so it's fairly easy to build. And then it looks like this. That was actually my initial one. It's a little bit hard to see from here, but one of the things that you should do, again, maintain your build plate well, as I mentioned earlier. If you keep your build plate nice and clean, the surface finish on this is excellent. It's because I am hyper attentive to my build plate. Here's another one, that's the object I passed around, the shitty radio case. That's the 2C VGA adapter. That's what it looks like. I intended to bring it with me, but it's sitting in my house. There we go. There's the 3D6 board that I built the case for. And there's what the case looks like. I thought about bringing that, it was a little bit too big. But it was a lot of fun to design that.
Oh, you need a big printer for that?
No, actually, I printed these all in sections. I don't know if you can see here, there's a lot of screws. Not everyone likes using screws. Charles, I don't think you use screws very much in your objects, do you?
I try not to.
I love nuts and bolts. Even if I don't have the right one, I'll even 3D print nuts and bolts to make an object. Usually you have to apply glue when you finish them so they'll stay. But one, I like the industrial look. I like old computers. I love nuts and bolts. And two, it makes your objects really strong. You can see here, I've got screws all along the bottom of here. And there's screws holding the floppy drive in the front and inside. And you can hide them. As you can see, I've hidden a lot of the screws, but it makes a really strong object. Otherwise, yes, you're absolutely right. You would need a large printer. And an object like this would be really hard to print anyway. If you look at this, that would be a heck of a support. Because this part sticks out, where the tabs on the top of your ISO cards are, you'd have to support that. You'd have a big old piece of plastic that you're just wasting on the back. And it probably wouldn't come out looking very well. So you got to print it flat on the surface. So one of the important things when making objects is to take them apart and make multiple pieces. So this is where most of my sources are. Wikipedia is a good source. There's actually a lot of links to really good sites on Wikipedia under 3D printing. And some information on Simplified 3D. So how much time do I have left, Martin? 10 minutes? Okay. So first let's do some questions. And then if we get past that, I will actually bring up and show some slicers. Dr. Buggy?
I heard on the news that just in the last week, the Supreme Court said that it's legal to make guns with 3D printing. Now,
Yep.
Would a plastic gun actually work? I mean, with bullets? And
It does, usually
would it-
once.
Would it get through the?
Yeah, literally, that's what it's designed for. If you think about it, does anyone read spy novels? I'm a big fan of spy novels. So if you read those spy novels, you would hear about spies carrying these microscopic little pistols that fire tiny bullets. They're real. If you ever go to the International Spy Museum in DC, you'll see some of these things. They'll come apart and they'll look like matchbooks or lighters or whatever. Even though they were made of metal at the time, they would only fire once. As soon as you fire it, it's going to come apart because they're not thick enough. But same with 3D printing. Believe it or not, you can actually print a surprisingly strong object. I was talking to Forrest earlier about replacing one of the supports in a 2C. The original object was made of nylon. I can print nylon. I can print with 100% density. It's one of the things I didn't mention. When you print, normally you don't print an object that's solid plastic. It wastes plastic, and plastic printed objects are really strong anyway. So if I printed a 100% density object and I try and fire a low velocity round, absolutely will work. Yeah, and it's kind of an important case too. Whether you believe in firearms or not, there has been a big discussion about whether it's legal to make an object of all kinds of object types, because there's all kinds of things I can make. I can make a plastic knife that's quite sharp. You have to think about those things. And you got to think about whether it's more important to be able to make or it's better to keep people safe. And it's an important discussion. I'm glad you brought it up.
Would a plastic gun get through the X-rays at an airport?
Metal guns do too, sadly. TSA is really bad. If you read some of the articles, there's a journalist who accidentally brought a 45. That's a big, heavy gun. So World War II officer's gun. He brought it through security. It was in his bag, and he'd forgotten about it. He turned himself in when he arrived, and he nearly went to jail anyway, even though he turned himself in. But they did not notice. It was in his bag, on his back, as he walked through an X-ray machine. It's a big old piece of metal. Question?
With photocopiers,
Mhm.
they require to embed a serial number.
Yep.
Microscopy, is there anything like that in the 3D printer world?
Generally not. Professional level printers sometimes will embed marks in them. You can make that happen if you want. But almost all these slicers that I showed you are open source, with the exception of Simplify 3D. So most of the open source community would consider that to be backdooring the user. Usually not a good practice. Other questions? Go ahead.
Yeah, I'm interested in what do you do to post-processing with regard to if you don't like the layering effects of the texture?
That's a really good question. I didn't bring that up at all. If you look at a finished product, again like this 2C, it's actually got a really nice finish on the case. Obviously this was injection molded, but depending on how you print your object and depending on how it was sitting in the build plate, you're going to end up with a different finish. The part of your object that sits on the build plate is going to have by far the best finish, assuming your build plate was clean. The other sides are going to be a little bit rougher, and you're going to see, like Peter said, you're going to see layer marks down the side. So depending on your plastic is the answer to your question. I have, because I mostly work in PLA, I sand. That is the easiest thing. You can sand and fill with putty. It's really easy. Generates dust. You got to wear a breathing mask and all that. So it's worth considering, but it's not a hard thing to do. If you're working with ABS, you can use other things. You can do what's called vapor smoothing. Charles, have you ever done that?
No, I don't actually do any of my own 3D printing. I send all my stuff out to Shapeways.
There's actually, that's a good point. That is something absolutely valid. If you don't want to own a printer, you can absolutely use Shapeways. I think I mentioned them before, but they can create things in quality that you cannot replicate. They're kind of expensive is the biggest problem. If you're doing what Charles is as a business, it makes perfect sense. He would never want to print those objects out, so you'd have to hand finish or paint or whatever. And there'd be a variation in quality. Even if you're meticulous about your objects like I am, still they vary a lot. So it wouldn't be worth it. It'd be way too slow. You'd end up with 50 printers in your house. It's not worth it. Use Shapeways if you're thinking about making a lot of an object. Question?
Where would you recommend someone get sandpaper of the quality required for finishing plastics?
Home Depot, Lowe's. Seriously, you can just get all the grades. Just if you want a really nice plastic surface, the only thing is that's special about sandpaper is you're going to gum it up with plastic. So you're going to throw it away pretty often. So don't buy really special sandpaper. Just get a regular sanding block. If you get a sanding block that's got a flexible surface, it'll contour around your edges. If you have one with a really hard surface, you'll get a better flat finish. But just buy various grades of sandpaper, all the way down to 200 grit.
I also find that I live in an area that
Mhm.
doesn't necessarily have a Home Depot or a Lowe's.
Okay.
Automotive parts store.
Yeah,
will have
yeah, absolutely.
Very fine sandpaper for finishing automotive parts, which often are plastic, that works excellent.
And that- and that
It's
actually-
very easy. You don't think about going to the automotive parts store for maker
Mhm.
space stuff, but they'll sometimes have the same sort of
Yeah.
tools for performing that sort of fine detail finish work.
Absolutely, and you can do other things that are useful there. Automotive paint sprayers. Thank you, Mark. Automotive paint sprayers are really useful for finishing your objects if you want to paint them. All those techniques, all the techniques that you watch auto bodymen do, if you watch on YouTube, they're great finishing techniques for plastic objects. Any other questions? Well, I guess I have, 3 minutes left?
I actually have a question.
Go ahead, Martin.
You mentioned that some printers produce better results for small, fine detail objects. Do you have any samples with you we can play with after?
No, I don't. But what I can do is I can send you some, or I can send you links to them. That would be SLA. That's usually what I suggest when you're talking about really fine detailed objects. Again, like floppy drive gears and things like that. You can print them with FDM, but you have to print them with a really tiny nozzle and print really slow. So, and normally when you're printing objects like that, the physical strength advantage that FDM has doesn't matter so much. Because the fine detail is the strength all of its own. You may know that when you're printing a gear, it's really important to get the profiles on the teeth exactly right. The most important thing is not so much how strong the plastic or the metal is in the gear, which is why you saw Apple or Chinon or TIAC use plastic gears in their floppies, but it's how well they mesh. So even if you have brass or steel gears even, if they mesh poorly, they're going to grind each other's tips off. You think about it, they're going to run into each other. And as you do this over and over and over again, they're going to beat each other up. With a bunch of metal or plastic parts in the bottom. But if they mesh really nicely, again, if you print something in SLA, it meshes very fine, can last a very long time. Go for it, Charles.
If anybody wants to see SLA or SLS laser centered parts to comparison, I have a few pieces that are with me, so you can see the comparison.
Perfect.
Cool.
Go see Charles.
Okay.
Yeah, absolutely. And it's really fun to play with the technologies. If you get into 3D printing, you're probably going to end up with an SLA printer and an FDM printer and a Delta and I just as much as I love vintage computers of all brands, I may be a little bit heretical, but I love all vintage computers. I love printers too. I like making them and modifying them and repairing them and all of it. It's incredible fun for me. I guess that's it, 'cause I think I'm about out of time. Thank you.